Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So slowly we have reached 29th of 75 problems from the Grind 75 list. Today's problem is on finding the longest substring without repeating characters. So we are given a string like this one and we have to find out the length of longest substring without repeating characters. Okay, let's jump into the problem statement and start solving. So last time we have solved the k closest points to origin. Let's start with longest substring without repeating characters. Okay, given a string, find the length of the longest substring without repeating characters. Two things to notice: we have to find the length and not the substring itself. Let's take this example. We have a b c, b b, and this answer is 3. The answer is ABC, the length is 3. So ABC is the longest string. Okay, let's understand this a little better. So this is a string. We can see out of this ABC is the longest substring without repeating characters, since all the characters are unique. Similarly, if we take BCA is also the longest substring, right? Similarly, CAB is also the longest substring, and another ABC here is also the longest substring. But since all the longest substrings have the length 3, the output is 3. Now let's do one thing. Let's create another longest substring in this example and see how we are going to code it. So we'll make ABC, AB, let's make it DC. Okay, so how we can solve it is, please take a minute and think of some approach to solve this question. Ready? Okay, so let's say we start with A. We see A, so we need, in order to find out, we see A, then we see B. Okay, after A we reach B. That means we need to know that what is the longest length by now, right? So how can we do that? We'll keep a count for max length. Second is, when we are at A and now when we reach B, we need to know that B does not exist already as part of the earlier string, which is A. So we need to keep track of the characters that have been added to our longest string as of now. So that means we should keep a list. We can either keep it as a list or hash map or hash set. Set would be much better since we can search it in the O of log n time complexity. So we need a set to store the characters. Okay, let's start again. We are at A, we reach B, we check it if B is already part of the set. No, we add it to the set, we increase the max length. Similarly, we take C, we check C is part of the set. No, we increase the max length to 3. Next is we get A. Okay, now by ABC we have already found out the max length was 3, but it can happen that in the rest of the string we can find a length bigger than this one, like we are going to find for ABDC, right? So how will we do that is, we will include this A and we'll remove the earlier A. Okay, so we'll create another loop to remove the characters from the string until this character, our current existing character, is no longer part of the string. So A will get removed and new string will start from BCA. So we need one more thing to keep track of B, right? So we need few pointers to keep track on the left side and the right side. So we need 2 pointers. We'll call them left and right. Now we started from B, we are at BCA, we see B again. So we add, in order to include this B, we start removing characters from the left side until this character has been removed. So B gets removed and now new character is CAB. And then we see D. We include D since D is not part of the set already. CABD. Now this length is bigger than our earlier max length. So we'll update our max length to 4. We'll follow the same procedure and in the end we'll reach the answer as 4, since 4 would be the maximum length out of this array, out of this string. Make sense? Okay, let's start solving it and let's understand it better. Okay, first Okay, first int n is equal to s dot length length, so that we have the length of the string. We'll have our max length equals to 0. We'll have our pointers, int left equal to 0, initialize it with 0, int right is equal to 0 as well. Okay, we'll create our hash set of type character, set is equal to new hash set. Done. Now we'll start traversing through the string, and since we'll be moving our front pointer, the left pointer and the right pointer in each string, and we'll actually be creating a sliding window. We remove character from this end, like in this case we remove the b from this end, we add the b on this end. So this is called a sliding window technique. I'll just name it sliding window technique, right, where we are using left and right pointers, right? Okay, so we'll check while right is less than n. So right will be the pointer which will be taking care of the characters that we have already considered in the list, and left will be on the initial end. Once we remove, we update the left pointer. Okay, so while right is less than n, we'll check if the character at right, which is currently at 0, is not in this set, add it and expand the window, right? So we'll check if not set dot contains s dot caret right. If this happens, we'll simply, so if the character is not contained in the list, like for a, we'll add it to the set dot add s dot caret right. Okay, similarly, since we added one character to the set, we'll update our max length is equal to math.max of our original max length, which is max length, or right pointer minus left pointer plus 1, right? So right is at 1, left it at 0. Sorry, right is at 0, left is also at 0 in the beginning. So right minus left, 0 minus 0, 0 plus 1, 1. So 1 is the length of the max length that we have found so far. But in case, and similarly, since a has already been considered, we'll move our right pointer. So we'll say after this right plus plus. Now in case the character does not exist as part of the set, sorry, the character does exist as part of the set, like when we had already considered ABC in the set and new A came up, right? We need to remove the first A. So we'll say if the character at right is in the set, remove the character at left. Why left? Because we will start removing the characters from the left pointer side. Left, and shrink the window. Earlier we were expanding the window, now we'll shrink the window. Okay, so we'll say set dot remove s dot caret left. Okay, and then left plus plus. So let's say our string looked something like this: A, B, C, and then we get A, B. We had already added A, B, C to our set. We found A here. Okay, it is contained in our set, so we removed the s dot caret left. Left was pointing to earlier A. This A got removed. Now left will point to left plus plus. Now left will point to B, right? And we'll say again left is pointing to B, and this new B is contained in this set again. So we will remove this B as well from the set. Or let's take another example. You have something like A, B, C, and then B. Okay, so A, B, C we had already added to our set. Let's say set values look like this: A, then B was added, then C was added. Now we found one B. So we'll say set dot remove s dot caret left. Left is pointing to 0. We removed A from here. Okay, B had come, but we removed A. Now A has been removed from the set, but A has been removed, left plus plus. Now left is pointing to B. Again we came here. If set contains right, yes, because right is pointing to this B, so it comes to else part. We again remove the character from the left hand, so B gets removed. B is removed, and then left plus plus, left will point to C. Now this time when we check again, is B contained in the set? It's not contained, so now B will be added. So B will get added. We'll update the max length. Since earlier max length 3 was bigger, max length will not be updated, and right plus plus. Right will move forward and will end the loop. That's all. And then in the end we can simply return the return max length. Okay, let's run it. This is sliding window technique. It's very famous and very frequently asked in interviews. So please very frequently asked in interviews. So please pay attention, remember it. It is used to solve numerous problems. Let's submit. Okay, beats 84.78% of the users. That means some of the users have used maybe algorithms better than this one, or maybe are using the same algorithm, but that is I leave that part to you. Please let me know in the comment section if you think there's any algorithm better than this one which can beat this time complexity. Okay, and we'll look at the better solution. So that is all from today's video, everyone. Thank you. Please like, share and subscribe, and regarding anything please let me know in the comment section. Thank you.